Hello and a big welcome back to all my subscribers, and if you're not a subscriber, why not? Right, today I just want to cover the DUART. I'm back to looking at the DUART in detail with traces and trying to work out what is going wrong with this thing. So I've had some issues and I've looked at the wiring. I believe it's mostly okay. I'm currently using the 10-pin serial. I'm also broadcasting on the 6-pin serial, but that doesn't actually, it's not connected, so it doesn't make any difference as it stands at the moment. Let me just show you the where we're at here. So this is one of my more recent traces. So what I've got here is the data lines, and then the WRN or write enable line, and then read enable line. This is the chip select or chip enable. Then this is transmit on A, transmit on B, receive on A, receive on B, and then the interrupt. Now, what we're seeing here in this tells us quite a bit about the DUART behavior. So the write enable line is toggling regularly, and so this is indicating that the CPU is actively writing data to the registers, and this is expected because I'm trying to initialize it in a loop to configure and or transmit data, so I'm actually trying to do all of those. So the read enable line, it's not active or high most of the time, meaning that it's not receiving, significant data reads aren't happening during this trace anyway. And so this could explain why the RxDB line remains low if the software isn't polling or whatever. And then the chip enable is always high, meaning that the DUART isn't selected, and this is a problem. So the DUART won't respond to reads or writes unless the chip enable is low, because the chip enable is active low. And so this high state is causing most of my problems. Now, I have looked at this thing, and initially it was set to an inverter, and I took that out because what should happen is when the multiplexer picks, in this case Y11, which is B, it should go low. It's normally high, it should go low. Right, so the other lines here, the TX and DA, transmit data lines, both are high idle state, which is normal if there's no active transmission. So this suggests that the DUART isn't doing any outbound, which is in line with the chip select being not working. And the RxDB is constantly low. So it confirms it's not being affected by external serial data. So this is likely a configuration issue or an incorrect DUART setup. But the interrupt request line is always high, which means no interrupts are triggered. So this indicates that either the DUART hasn't detected an event like received data or errors, or the interrupts aren't properly enabled. So what I need to work on first here is find out why this thing is not going high. So if we quickly look at the bootloader, I just kind of move all this out of the way and make it so you can see it. Down here I got the base, so this is B, and it should this is the actual DUART address. It should be selecting this, which would mean that the multiplexer should go to Y11, which should enable this chip or bring it low. So I'm loading the base address into A, and at that point I should then get the multiplexer returning to a low state, which should enable the DUART, which would then mean that all of the following can happen. But this isn't happening. This is not happening. Now, I cannot work out whether this is a wiring thing, but this is my next step in diagnostic. So I'm going to find out why this isn't going, why this is always high, and this forces the DUART to ignore reads and writes. So my GPIO, that memory did work. So I'm sure that the multiplexer is not broken, so I don't think there's a problem with the actual hardware. But there must be something wrong with the software that I'm using. The WRN active without proper effect, so since this is high, toggling the WRN isn't reaching the DUART, so it isn't accepting any data. So in theory, once I fix this, the chip enable, the write operations should work properly, and the RxDB being constantly low, this may be misconfigured B channel. So once the chip enable is fixed, then down here I should be able to properly configure the B channel. But I can't do anything until that chip enable is fixed. So my next step is to go back to basically the hardware and try to work out what's going on here. So this is the problem child. The multiplexer chip doesn't seem to be selecting the DUART, and that is the problem. So once I figure out what's going on with this, I should then be able to start getting signals up and down the serial ports, A and B. So that's where I'm at. Now, one other quick announcement. One of the things I'm also working on, or I've decided to work on as a sort of a secondary project to this, is eventually when I do this, I'm going to need an operating system. And so what I'm doing in the meanwhile, whilst troubleshooting this, I'm also working on creating my own operating system, and I can start doing that with a virtual machine and an emulator. I don't need the hardware working to work on that bit. So when I get a bit bored with looking at these wires, I flip over to that. So I will probably do a separate video series on the actual operating system and the software that I'm using to do this. I started that this weekend, and it literally took the entire weekend to rebuild the GCC tool chain and add newlib, which is a small C library, the standard library, because I need a cut down version of the standard library in order to create the kernel for the bootloader to call. Anyway, that's where I'm at, and I hope you enjoy these updates. If you do, please like and subscribe and share them around and all that good stuff. Alright, thanks a lot. Bye.